Hello, everybody. My name is Stefan Meerwald. I am the speaker of the working group safety, that is functional safety, and the working group safety addresses all topics that are related to functional safety according to the ISO 26262, that is end-to-end protection and public platform health management and functional safety architecture and some similar topics. Today, I want to introduce two new concepts for this year's release. That is the first one, Safe API for a hardware accelerator, and the second one comes immediately afterwards. That is the time validation concepts. So let's start with the first one. That is Safe API for hardware accelerator. So with a Safe API for hardware accelerator, we want to solve a problem that is we have some processors, some hardware resources for high-speed computing. So the hardware accelerator. So in embedded software, there's usually the need for a fast and safe computing that especially is either if a lot of data is used, data-intensive computing, or if very complicated algorithms are used, so algorithm-intensive computing. So if the hardware of some chip offers these possibilities, so why shall AUTOSAR not use these resources for high-speed computing? So as a comparison, we can see these hardware features, the equivalent of a library for high-speed computing. We simply deliver tasks for high-speed computation to this library, or in our case, to hardware accelerator. So as a library, it is intended for speedy computing, but usually speedy is not automatically safe. So we do not only need speedy computing, but also speedy and safe computings. So the usage of the hardware accelerator faces a problem if we are bound to safety issues that are defined in the ISO 26262. So up to date, AUTOSAR does not offer an access to this hardware accelerator for safety relevant computing. The solution is, if this interface does not exist, let's define one. So the concept team decided to use an already existing API, the Kronos SYCL 2020, for two reasons. It is it attempts to be safety relevant according to this ISO standard 26262, and it also supports different hardware platforms. So why do we need this for the adaptive platform? Where we have use cases, for example, the sensor fusion with data from multiple sensor sources. So this is data-intensive usage, or LiDAR point cloud computing, that is collecting data from the near environment. This alone is intensive, but to compute it, we also have to consider that the observer, that is the existing car that collects this data, is moving by itself. So also a compensation of the self-moving vehicle must be considered for the computation of the LiDAR data. So let's mention some restrictions. So the usage of hardware accelerator is possible if exactly this hardware is used. It is not allowed that the adaptive application that needs this data accesses the hardware accelerator directly, only via this API. And it's also not supported that, for example, one hardware accelerator shifts tasks from one ECU to another, so that another ECU hardware accelerator from another ECU supports on a computation task. This the concept is limited on one an ECU. So how would the architecture look like? So we see here on the left-hand side the adaptive application that needs some computation task. So it accesses the API, the safe hardware API, and these two is combined with a vendor specific implementation code. So why do we have a vendor specific code in here if it has a standardized API? Well, this can be seen similar like an MCAL, which has a standardized interface to the upper layer and a proprietary interface to the lower layer, because the hardware from each vendor, from each processor supplier is different to the hardware of another. So the vendor-specific implementation covers the tasks to use the hardware support as best as possible. So this combination of both is the safe API that allows to use the speedy resources for computation. So let's have a look at the functionality. What is the general functionality that is provided by Safe API for Hardware Accelerator? If you have a data-intensive computation, of course, this data has to be stored. It has to be stored efficiently for computing and also safe. So this is one main task of this Hardware Accelerator, the safe storage of a large amount of data. Then the task execution, simply it is asked to queue the different computing tasks to it, and event and error handling. That means get the intermediate or final results. Was an error, and what was the current result of a computation? So simply a kind of supervision of intermediate steps. And also we have device management and monitoring. That means the abstraction of the whole hardware. So it is simply a hardware independent monitoring, and also to get the results. What is the current status of a hardware accelerator? Is it healthy? Did there occur some problems, or is there simply high load, so that any further task should not be submitted to the hardware accelerator? Yes, at once. And last not least, runtime configuration. So the whole hardware accelerator, the shell shall not be very constantly. Of course, it shall be configurable, like any other AUTOSAR component or module also. So in combination, we have here an interface and a possibility to use hardware resources efficiently for safe and speedy computing. So this is the general purpose of safe API for hardware accelerator. This concept is applicable to the adaptive AUTOSAR, because the adaptive AUTOSAR is also defined for large data and high dense computing.